Hi students, this is your lesson for Unit 3, Day 2. Our learning goal today is that you can write the equation of a sine, cosine, or tangent function given the graph, table, context, or description of transformations. So in this video, we're going to actually work on sine and cosine equations given a graph, and this will be the basis for you to explore during our class time together. Criteria for success: when you're writing an equation for sine or cosine, you will first identify all the parameters, and then you will write the appropriate function incorporating all those details. Reminder that our equation for a sine or cosine function, the a value is going to tell us the amplitude. It will also tell us if the function perhaps reflects across the x-axis. The b value is going to remind us that we have the period times the b value, their product, is equal to 2 pi. The h value is the horizontal shift, and the k value is the vertical shift. The k value will also help us find our midline. So we're going to start out with this graph, and the question is going to ask us to find a sine function. So the first thing I want to look at, and this doesn't have to be your first thing, but I usually look for the midline first. And I'm going to record everything I do, and this is going to be y equals 1. So the midline is y equals 1. This also is a vertical shift of 1. Okay, now the next thing I'm going to think about is the amplitude. How high above the midline or how low below the midline is my graph going to produce outputs? So it looks like we are going up a distance from the midline up to the maximum. We're going to have a total of 2. And the same thing from the midline down to the minimum. That would be exactly the same. And we would have 2 here as well. Okay, I'm going to get rid of that so my picture's not too crazy. All right, so now we can say that we have the amplitude is equal to 2. Now we want a sine function. So I am going to highlight one period, one full cycle. And we know when we're looking at sine that we have 3 points here located on that midline. Now something that strikes me right away is that I start to go down first and then up. This shows me a reflection. So I'm going to say reflected across the x-axis. The next thing I want to look for is the period. How long does this take one cycle to complete? Well, it starts at 0, it ends at 2 pi over 3, or 2/3 pi. So the period is 2/3 pi. Now, we really need to find the b value in order to write an equation. So we should write PB equals 2 pi. We're going to write 2/3 pi times b equals 2 pi. We would divide both sides by 2/3 pi, and when you do that, you get a b value of 3. So let's see if we can start writing this function. F of x equals, the a value is the amplitude, which is 2. I also see there's a reflection, so I'm going to write this -2. We were told to use a sine function, and we found the b value to be 3. Now, we also want to make sure, is there a horizontal shift? And in this case, no, there is not. We're starting right here. We didn't shift to the right or left. So in parentheses, I can write 3x. And then we can't forget about that midline, that vertical shift of 1. If you got something different than I did, there's actually an infinite number of ways to represent this with different various shifts. You can actually put my equation into Desmos, put your equation into Desmos on a second line, and if they graph the exact same function, you're in business. They actually are equivalent representations of the function. Okay, let's take a look at number 2. Now, I would recommend pausing and trying to see if you can figure out this cosine function. Okay, so when I'm looking at this, I want the cosine function. I'm looking at a midline that's right on the axis. So nothing too crazy there. So midline is just y equals 0. So that means no vertical shift. Now, let's see. Let's take a look at our amplitude. It appears that we're just going up 1 from the midline and down 1 from the midline. So amplitude equals 1. Now we want to write this as a cosine function. So I would like to start here and end here. Now let me tell you again, there is more than one way to write this function correctly. I'm not expecting you to read my mind. So if you chose to represent it a different way, you're still very likely of getting the same exact graph when you go ahead and try yours. So when I look at this, I want to say, what is the period? So the period goes from 1/2 pi to 9/2 pi. Okay, so let's think about that. That looks like that would be 4 pi. Okay, we don't want the period necessarily for the equation. We actually want the b value. So PB, the product of P and B, is equal to 2 pi. I input 4 pi for the period, and then I go ahead and I solve for B, and I get 1/2. Now the other thing we need to remember is that it looks like we shifted to the right 1/2 pi. So this is a horizontal shift right 1/2 pi. And now I think we're about ready to write our equation. So f of x equals, we're going to do a cosine. So let's think about this. There was no reflection, so we have a positive a value, and the a value is just 1. So we don't even have to write anything there. We can right away just go with cosine. Now in this case, we found our b value, which is 1/2. We also have a horizontal shift, and the shift is to the right pi over 2, so we're going to subtract pi over 2. There is no vertical shift, so this is your equation. Again, if you wrote something different, don't mark it wrong. Type both equations into Desmos and see if they produce the same graph. Depending on how you looked at this, first of all, you could write this as a sine function. This did say to use cosine, but it's possible to write as a sine. You could also have looked at different parts of the graph and written it with different shifts. So no matter what, if you have a different equation, if it produces the same graph, then it's just as fine as any of the other equations. And I'll be reading all your equations, so I'm not expecting you to pick the one that I'm thinking of. Okay, thank you students for taking notes and watching, and I look forward to working on this with you in class.